Okay, this is the second part of the Exponential Growth and Decay video series. I would like to now talk about compound interest. So if you see that your word problem is referring to money and it specifically talks about compounding interest, then you will be using this formula that's shown, that's highlighted. So that formula is read A of t is equal to P times the quantity of 1 plus R divided by N, all raised to the power of NT, where A of T represents your amount after T. And so that basically means, just like I said in the first video, what will your amount be after a certain amount of time? So for instance, if I started out with $300 and I have a specific rate, what will it be after 5 years? So that's what A of T represents. P represents like your initial or original amount or your principal. So there's different words for that. It means the same thing. And you're going to use 1 plus in the formula. R, we saw that in the last video, represents rate. And when you're using your rate, your interest rate specifically, you're going to change it from a percent to a decimal. And I showed you how to do that in the last video in part 1. So if you need to go back and look at that, please feel free to do so. In terms of my N, well, I'm seeing that 2 times in my formula, so pay attention to that. And that represents the number of times that interest is compounded per year. Now, I want you to pause and take notes because this will come in handy. It specifically tells you what your N will be depending on the verbiage that's used in your word problem. So if it says annually, then your N is going to be 1. Semi-annually, 2. Quarterly, 4, so on and so forth. So take the time to write that down. That is what your N will be. And then finally, T represents time, which is in the number of years. And that's going to be multiplied times N. So, all right. So like if I have this specific word problem, again, I want to dissect what it's saying. So Samantha is planning to buy a car. She invests $3,500 in a bank account. So she invests, that means like her original amount that she started with. And if I'm looking at my variables shown over on this side, that initial principal or amount is going to represent P. So I know that P is going to be 3,500. And then if I keep reading, it says that she invests 3,500 in a bank account that compounds quarterly. Compounds quarterly. So that's when I go to my N and I look to see, well, which one of those N's represents quarterly? 4. So I already know that my N will be equal to 4. That's why I said you want to take the time to write that down. So it's compounded quarterly at 2.5%. All right, we know that that's a rate, and we also know that it cannot be shown as a percent. It has to be converted to a decimal. So R is going to be 0.025. And I showed you again how to do that in my part 1 video if you need to know that. And lastly, we're either going to have A of t or we're going to have T. So we have to pay attention to what the question is asking. So A of T is the amount after a period of time. So what are we looking for? It says, how much will she have saved in 2016? Well, yes, we are going to be looking for A of T. So I know that's what we're trying to find. So therefore, we also should have T in our problem somewhere, but I don't see it. You do, you just have to do a little bit more work. So how much will she have saved in 2016? So we know that's a date, but when did she start? Well, she started her investment in 2010. So sometimes you'll have problems like this, and what you have to do is just take the difference. So how many years is that? Time is represented as a number of years. So T is going to be 6. Take that information and now you substitute it into your formula that's shown here. All right, we know that we're trying to find A of t, so A of t equals P. Let's go back up here. So it equals P, which we know is 3,500. And then the formula tells us to multiply times 1 plus the rate over the number, or n. So the rate is 0.025 and n is 4 because it's quarterly. And then we're going to raise that to n times t. N is still 4. So both these numbers should look exactly the same when you're using this formula, times t, which we just said was 6. All right, so once I put this in the calculator exactly how I see it, including the parentheses, then my answer is going to be A of t is equal to, and we're talking money, $4,064. And if you want it, you can put the cents, approximately 52 cents. So this will be your answer for this problem. If we were using that same scenario, the wording will be a little bit different for a problem like this called compound continuous interest. This is the formula you would now use. So again, we still have our A of t, our principal, and our interest rate and number of years. What we don't have is n. We don't need to know what the compound rate will be annually, weekly, quarterly, because we already know it's going to be continuous. So reading this problem, it says Samantha is planning to buy a car. She's still investing at $3,500. Well, we determined in the last problem that that represented P, which is her initial amount or her principal, and a bank account that compounds. This is what you're looking for. If you ever use this formula, you have to see that word in your word problem. So continuously. So if it's going to be continuously, just think, well, PERT. That's how I remember it, P-E-R-T, where E is not a variable. You notice I don't have that listed over here. E is a number, which is approximately 2.718. We discussed this before when we were talking about logs and exponents. We're still talking about exponents. So just keep that in mind that you are not trying to replace E. It is actually in the calculator right above your natural log button. And it may ask you to raise it to a degree. It may look like this in your calculator. If that happens, just put a 1 there. That's all it's asking for. Okay, continuing on. At 2.5% for 6 years. So this time they specifically told you the time was 6 years. And the rate, we know, has to be converted. So 0.025 is still the same rate. And then again, time is 6 years. So I have it a minimum of 3 of the variables, which is, well, I need to have 3 variables in order to solve for the A of t. So I have enough information to solve. How much will she have saved? So we're going to do a comparison between if she had just did compound interest quarterly versus continuously. So A of t would equal, and then I'm substituting in for P, PERT. P is 3,500 times E, and your calculator will again give you a number, which is approximately 2.718, raised to the 0. Well, you don't have to put the 0 unless you want to, 0.025 times 6. So make sure when you put it in your calculator that you put it in correctly. If you do this, your calculator will tell you that she would have saved approximately $4,066.42. So had she gone this route, she would have saved a little bit more interest versus that first one. See the difference? So it's close. It's a couple of dollars more. So this is good information to know. So when you're trying to plan to buy your car, you can go ahead and do some comparison shopping for banks to see what their interest rates are. All right, you guys, subscribe and like the video. Thank you.